They said you wouldn't make it so far.
Are you interested in finding a school to enhance your education? Not sure where to start? Well, today your search is over. CDP Maths Lab eSchool offers classes for C.S.E.C, CAPE, and GSET subjects, along with training in early childhood education and data operation. Listen to what CDP Maths Lab students have to say about their most fulfilling experience.
While I was attending, it was almost the best experience I ever had. Like I was in class, but I wasn't. I would give the school the full 10 out of 10 because the teachers take the opportunity to help the ones that really needed it. To the upcoming students, this is the best decision you have made and it will benefit you in the near future.
Talk to your soul and say, I can.
CDP Maths Lab eSchool was founded by Ronique Bernard in August 2009 with a vision to see our students receive a solid education with an emphasis on developing their cognitive skills. The school is committed to developing individuals who will have a positive impact on the society.
The class it really helped me, and if you are going to see C.S.E.C, I really recommend this class, so you could always give it a try. The prices are really reasonable, and it is really worth it for online class. Like myself, you would be proud because on that day or on that night when results are out and you log in and you open your results, that feeling, it really is great. It is more of an experience that you would really want to relive.
Of course, I went through it and I passed my exams, so I would highly recommend this to anyone. If you have a problem or so, they will take their time out. They will take their time out to tell you. Plus, they have history of also past students who have also passed their exams in once.
I have been attending for 6 months, and my most fulfilling moment would be the interaction between the teachers and the students, as the environment is very comfortable and welcoming. On a scale of 1 to 10, with 10 being the highest, I would rate this institution, along with the teaching techniques, skills, and tolerance of the teachers, a perfect score of 10. If I had the opportunity to recommend someone to this class, I would, because I can assure you that you will leave 10 times better than how you had entered. Now that I am leaving, one thing that I would recommend is a classroom interaction at least twice a month, as some students tend to do better with face-to-face interactions. This program would be the best decision one could choose, as the teachers are excellent at what they do, and they will go to the extreme to ensure that you understand what was taught, even if that means staying up with you all night. To CDP Maths Lab. Thank you.
Despite his late start, Shonday was able to successfully complete his exam.
Trust me, it's a really good program, because if I entered a month before exam and I passed the exam, that says everything for itself. The program speaks for itself practically then.
Just start to believe.
CDP Maths Lab eSchool is convenient and economical. We provide flexible learning options in a relaxed environment. With over 80% pass rate, we offer free demo classes before payment, one-to-one interactive tutoring, clinical teaching sessions to strengthen weak areas, and step-by-step video and worksheet exercises.
Good night, sir.
Good night. Good night.
Oh, good night. I thought my mic was on. I want to say a special good night to once again those students from Mr. Foster's class, like Jaron Harrison. Good night to you, and good night to Alicia and all other um, persons who are viewing the classes live from our YouTube channel. Now we're going to first begin with devotion, and we'll be reading from Genesis chapter 3, verse 6 to 7, and I'll be reading just verse 6 in your hearing. Okay. Now, it says, when the woman saw that the fruit of the tree was good for food and pleasing to the eye and desirable for gaining wisdom, she took some and ate it. Now, I want to stop right there. Now, we all know the story about Adam and Eve, and there are lessons we can learn whether we believe if the story is true or not true. There are lessons we can gain from this story. Now, first of all, okay, right? Now, first of all, I got it. First of all, when you see that God told her not to touch that tree, and instead of listening, she went and listened to another person and lose sight of the instruction that was given to her. Now, we must be careful of the things that we look at. Not everything that you look at is good for you. Not everything that you look at, you must desire. And because of Eve's not listening to instruction, for example, we as your teachers, if you don't listen to our instruction and you do what you wish to do, then you must recognize that the consequence of not listening is going to be equal to the consequence of Eve not listening while we're experiencing what we are now experiencing in this time of the world. So one lesson we can learn from this is that a wise man listens and increase learning. All right. So we're going to listen to our theme song for devotion, and I'll ask Tangini to take us in prayer. Let's go.
I love you, Lord. Oh, your mercy never fails me. And all my days I've been held in your hand. From the moment that I wake up until I lay my head, oh, I will sing of the goodness of God. 'Cause all my life you have been You will lead me through the fire, and in darkest night, you were close like no other. I've known you as a father, I've known you as a friend, and I have lived in the goodness of God. Yeah. And all my life you have been faithful. Oh, and all my life you have been so, so good. With every breath that I am able, oh, I will sing of the goodness of God. Yeah. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. With my life laid down, I'm surrendered now. I give you everything. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. With my life laid down, I'm surrendered now. I give you everything. Your goodness is running, it keeps running after me.
Okay, let us pray. Most kind and loving and heavenly Father, we take this opportunity to give you thanks, oh God, for allowing your goodness to keep running after us. Therefore, as we're about to, participate in a teaching and learning environment once again, the teaching of mathematics, we want to give you thanks, first of all, for our guest teacher, Mr. Foster. Pray, oh God, that you'll be with him and his family. We know that this day would have come, and we pray that you'll be with him and lead him throughout tonight's procedure. We want to ask to be with the students who are in Zoom, students who are viewing on YouTube. They're all preparing for exams, dear God. And we have but less than 2 months, but we know that all things are possible with you and through you. And so, Father, we ask that as they continue to study, continue to depend upon you, may you continue to open up their cognitive skills, develop their cognitive skills, that they will be successful, they will be able to read the questions, they'll be able to recall that they need to recall and apply themselves. And at the end of the day, may your name be honored and be glorified in their success. In Jesus' name we pray. Amen. All right. Good night, Tasha. Good night. Good night to everyone.
Good night.
Yes, good night. I want to say good night again to Noah Levy. Special good night to you as well, and all other persons who are just coming on. Tonight, our instructor will be touching bearings and a bit of algebra, functions, and relations, and there will be a part 2. Now, I want to say a little bit about our presenter, Mr. Rasheen Foster. Now, Mr. Foster did this subject. I hope he doesn't mind me saying it, right? He did this subject in grade 7.
You can go ahead, man.
Thank you very much, Sir Foster. In grade 7, and he got a grade 1. Is this teacher here? If you think I am good, well, he's great. And he has done marvelous things with students up to last year. They have done very well. So I know that his students would say the same in the YouTube chat there, right? So you're in good hands tonight, great hands tonight. I just want to you don't be afraid to ask questions. For those in the YouTube chat, I will, as you ask your questions in the chat, I'll say it to Mr. Foster, and then and he knows he will reply to you as well. And for those of you in Zoom, I pray that tonight will be a blessing for you, and that you'll take every bit of what you're about to learn. Now, just to inform you, near to the end of the class, we'll be having our quiz, and those persons who are on YouTube will also be able to participate in the quiz. All right. So good night there to Teresa, and good night to Gabriel as well. So I'm going to, without any further ado, I'm going to allow Mr. Foster to begin his session right now.
Okay, so firstly,
Over to you,
a
sir.
pleasant good night to everyone who is viewing. Thank you, Mr. Bernard, for having me. It's a pleasure, and I'm always here to help and provide my support, because that mathematics and the teaching and the love of mathematics, that's what we are all about.
Yes.
All right, people. So let me just introduce myself a bit. So as you were told before, my name is Mr. Foster. I'm a teacher of mathematics at the Holy Trinity High School. I've been teaching mathematics ever since I was in first form, because as he said, I did my C.X.C exam when I was in first form. All right. So what that means is that I am a living example to show you that it doesn't matter how old you are, it doesn't matter how young you are. It's just about the learning, the way how you learn mathematics. And I just want to give a special thanks to my father, who's also watching right now. My father, Mr. Foster, Brother Foster from Campion. Everybody who goes to Campion knows Brother Foster. He is the one who taught me all of those principles of mathematics that made me able to do C.X.C questions from I was in like grade 3. So everything that I learned and everything that I'm going to impart to you guys now is all thanks to him, and of course the Most High. So that's just a little introduction to myself. So first, I just want to give you guys an idea of what I want to run through with you for a bit today. As you can see on our screen, we're going to be doing a bit of bearings. And bearings is a question that is centered on a few topics. The major thing is trigonometry. All right, so that means that you have to know your sine rule, your cosine rule, things like your trig ratios, sine, cosine, tangent, also a bit of your Pythagoras as well. All right. But you also need to know a bit about angles. And so I just want to do a quick review of some angles, and more specifically the angles that are formed within parallel lines. All right. So let's just run through these questions quickly here. All right. So we want to find the missing angles here. Let's look at the first one here. All right. So can anybody tell me, do you have an idea of how do you think we can find A here? Anyone, right? So if you look at what you're given right here, how do you think you can find either A, or how do you think you can find the angle marked B? So if I have two parallel lines like those, and I have two angles on the inside, what are formed are called co-interior angles. The word interior, like interior decorating, where you decorate the inside of a house. All right, so these types of angles, they are supplementary, and the word supplementary means that they add up to 180. So if I look at what I have here, A and 110 are an example of those types of angles. So when I take the 110 from 180, A would be equal to 70. It's the same thing for B right here. B and 80 are also co-interior. So when I take the when I take the 80 from the 180, I would get B, which would be equal to 100. Let's look at the next one quickly here. So we have our parallel lines there. Right. So there are some special type of angles now that form a Z. Those types of angles are called alternate angles, and those angles are equal. So that is what this question is based on. But if you look, you would realize that you also see a triangle, and you see a line here and a line here. And in mathematics, when you see the same number of strokes on two lines, it basically means that the lines are equal in length. If these two lines are equal in length, then that therefore means that what we have right here is called an isosceles triangle. So in order for me to find either of these angles, I take this 65 from 180 and then I divide it by 2. When I take my 65 from 180, I get 115. When you divide that by 2, That gives you 57.5 degrees. So both of these angles right here would be equal to 57.5 degrees. Using that knowledge now, if I now look right here, you should see the Z being formed, which means that the angle F and the angle C are equal. So if C is 57.5, F is also 57.5. If I look right here, I also see a Z. So if if E is 57.5, D is also 57.5. All right, so I'm not going to look at any of those other two because I said these are just two quick revisional questions. So let's move on ahead. So what are bearings? A bearing is defined as the angle measured in a clockwise direction from a north direction. Bearings are used to represent the direction of one point relative to another. So let's say that you're downtown and you're trying to think about where half a tree is from where you are. Let's say that you're downtown on, let's say, King Street where the Mothers is, and you're trying to think about getting to half a tree where, let's say, Tropical Plaza is or something like that, right? When we talk about bearing, it is basically the angle that would be formed between the 2 points, where you are and whatever you're trying to think about, wherever you're trying to think about going. All right. So it's basically representing the direction of one point relative to another point. When you're doing bearings, the most important things for you to be able to always remember are these things right here. So I want you guys to try your best to make sure that you write these down. So I'm going to give you a little bit of time to write these things down here. And then we're going to go through it and we're going to see how we're going to use these principles to answer any type of question that you're given. One of the major problems that people have with bearing questions is that they do not know how to draw the diagrams, how to sketch the diagram, because each question requires a diagram. If you're not able to sketch your diagram, or if you have not sketched your diagram properly, then you will not get the correct answer. So let me give you 2 minutes or so to just write down this. So you don't need to write this part right here, but where you see note 12, make sure that you have these notes so that when I speak, you have them here to look back.
You want to turn landscape, Mr. Foster? So we can still look on YouTube.
So bearings are written using 3 digits. So example, if you have a bearing of 5 degrees, it is written as 005 degrees. So if you're doing a bearing question and you do not use the 3 digits, you are going to get your answer wrong. All right, so these are some of the things that you have to make sure that you pay special attention to if you want to get your questions fully correct. All right, so bearings are written using 3 digits. If you have a bearing of 5 degrees, it is actually written as 005. And remember again that a bearing is an angle. So whenever you see the word bearing, just make sure that you think about an angle. A bearing of 75 degrees is written as 075. So just always make sure that you utilize those 3 digits. Next, angles are always measured in a clockwise direction. And if you're not sure what clockwise means, it's just basically the same way that the clock goes. All right, so angles are always measured in a clockwise direction. Next point, angles are always measured from a north line. And when we get a little bit more into this and our cardinal points, your north, south, east, and west, you will see how important it is to always make sure that you draw your north line. Next point, So when you get a bearing question, you'll get something that says the bearing of point A from point B is 60 degrees. A lot of persons are not sure what to use as their starting point when they're drawing their sketch. And a lot of persons make the mistake of not using the correct starting point. And if you do not use the correct starting point, then your answer is going to be incorrect. So this can help you to know what to use as your starting point, because most of your questions are going to have the word from in it, right? So like 95% of the questions, you'll see the word from in it. And so the word from is used to represent the starting point. As I said, as you start drawing those sketches, you'll see how all of these points right here are important. The last point, a sketch based on the information is always required. So if you're not given a sketch, and sometimes they will give you the sketch, but if you're not given a sketch, then you have to make sure that you know how to be able to draw that sketch. And that's the first we're going to look at today. We're going to look at drawing the sketches of these, but we're starting with the simple ones because I'm just doing a little introduction of bearings today. Right? Let's say there's going to be a part 2 where we get into the C.X.C style questions. But for today, we just want to make sure that we have those principles down that we're going to need to know to answer any question at all that we. Because when I teach, I don't teach questions, I teach principles. All right. So when we're finished today and we start going into those in our part 2, then you will realize that any question at all that you get, you're able to break it down to get your answer. Let's it. And remember, if there's anything that you want to ask, you can say so before we move ahead if you're not sure on our so. All right. So cardinal points. A lot of persons take this for granted, but I'm a teacher. I don't take anything at all for granted. Mr. Bernard will tell you that. So I always make sure that I at least touch everything that you need to know to make sure that we have covered a little bit of everything that you need to know before we go into what we need to do. All right. So in order to do a bearing question, you first need to have full knowledge of the different cardinal points and the angles that represent them. The 4 main directions of a compass are known as the cardinal points, and those are your north, south, east, and west. North represents 0 or 360 degrees, and as you can see, I'm using my 3 digits here. East represents 90 degrees. South represents 180 degrees, and west represents 270 degrees. All right. This information right here, very important. There are going to be times where you'll get a question that says P is 50 kilometers due east of Q, or A is 100 kilometers due south of T. So when you see those words there, when you see the cardinal points, you have to know what angle they represent, right? You have to know what angle they represent so that you can use that knowledge to help you to answer any question that you're going to need to answer. All right. So in order to do a bearing question, you have to know your cardinal points. The 4 main directions of the compass are what we call our cardinal points. Those are our north, south, east, and west. North represents 0 or 360 degrees. East represents 90 degrees. South represents 180 degrees. West represents 270 degrees. Okay, let's move ahead. So draw a little sketch of that diagram quickly for me, please. And And again, we're just going through all of these basic principles so that when I start doing some sketches, I don't have to be repeating the same thing over and over, or so that it's a lot easier for you to understand what exactly we're doing and the reason behind what we're doing. Because the key thing in a mathematics question is that you have to understand the reason why you're doing what you're doing. What is the principle that you're using, and what is the reason why you're using that principle? Right? So what we do in a question cannot be random. It is never random. All right. So it has to be calculated based on what you're given and the knowledge that you have. So whenever you're answering a question, I tell my students, I never want you to guess. And I always give them little tips that they can use to help them to break down any question, because when you're doing a C.X.C question, you're marked for reasoning, comprehension, and knowledge. So a lot of persons have the knowledge, but they don't know how to reason out questions, right? So I try my best to show you those are the tips that you can use to help you to break down a question, and then you follow your principles and get your answer, right? No one knows exactly what the questions are going to be in C.X.C. All right, so if you get a bearing question, we don't know exactly what the type of question is going to be. Right? So what I have to do is to ensure that I put you in a position where any question at all you get, you can answer it by simply following your principle. All right, let's move on ahead. All right, so let's do some sketches now. So let's do some sketches now and ensure that you write this down. Your sketch must always include the north line, the bearing, which is the angle, the starting point, and the ending point. And since we have gone through the information that we need, we are now at the interactive part of our lesson here. So I'm going to start asking you guys some questions for you guys to answer me here. And these are the questions that I'm going to need you guys to be asking yourselves when you get one of these questions, so that you can know exactly how to answer it. All right, so use a diagram to represent the following. Question 1, the bearing of P from O is 70 degrees. So the bearing of P from O is 70 degrees. The first question that I want to ask is, what would be our starting point? Is the starting point going to be P, or is the starting point going to be O? And how do we know that that is our starting point? So the bearing of P from O is 70 degrees. Who can tell me that now? P or O, which one is our starting point?
P.
You think it's P? Why do you think it's P?
Sir, I think the starting point is P because
Don't be afraid to say why. Why? Right? And remember the information that we looked at. What was the information that I asked you guys to write down to always be able to help you to know what the starting point is? What is the word? What's that special word that you're supposed to look for? Starts with an F. Which one of those words?
From.
The word from. All right. So let me ask you a question now. Right? What if I saw you on the road walking one day and I said, hey, where are you coming from? And you said, I am coming from home. So let's say I saw you in half a tree, right? And I said, where are you coming from? And you said, I am coming from home. Where is the starting point? Is your starting point halfway through where I saw you, or is the starting point home where you are coming from?
Home where you're coming from.
Home where you're coming from. So let me ask you this question again. Let me ask this question again. The bearing of P from O is 70 degrees. What do we think is the starting point?
O.
P or O? O is the starting point. Does everybody understand that now? Miss Tangini, do you understand that now? Do you understand why it's now, why it is O and why it isn't P? Right, Miss
Yes,
Martin, Miss Lexley, Miss I don't know if that's a Mr. or a Miss Gooden. All right. So we say that the starting point is O, and that's the first thing that you have to be able to identify what the starting point is. All right. And as I said, most of the questions are going to have the word from in it. So that's all you need to think about, right? So from this, from that, from wherever, that is the starting point. So our starting point is O. So you have your little point. That is our O. The first thing that you always do when you identify your starting point is to draw a north line. You are now going to see why I told you that knowing your cardinal points are very important. All right. So again, step 1, determine our starting point. Step 2, draw your north line. And then the third step, we now need to try to estimate where the angle would be. Let us draw back our cardinal points again. All right. North is 0. Does anybody remember east represents what again? What
180.
angle does east represent? No, not the 180. Which one is it again?
90.
90. South represents? South represents the 180. And west represents 270. All right. So you're always going to get a bearing or an angle from most of the questions, and you have to use that to help you to figure out where to put your angle in your diagram. So remember, there are a few things that I say, as I gave you to write down, there are a few things that you always have to remember. Apart from the fact that you always use 3 digits to write or represent your bearings, a bearing is always measured from the north line. So always start at the north line. So that's the reason why I always have to draw a north line. So always start at the north line, and then you go in what direction? Was it a clockwise direction or was it an anti-clockwise direction? Which one did we say again? So was it clockwise or was it anti-clockwise?
Clockwise.
Clockwise. And is clockwise to the left or to the right? I just want to make sure. So to the left or to the right? And remember, clockwise means that you're going the same direction as the clock. Right? I've never seen a clock go this way before. Right? So it's going to be the right. So please, people, always remember that. Start at your north line and then you go to the right. All right. Can anybody tell me now, the angle which is 70, is it going to be, is it going to be between north and east? Can you see how it's going to be between north and east? Because if north is 0 and you always start at north and go this way, if I want to go an angle of 70 degrees, it has to be somewhere in here. Do we all see that? North, 70 has to be somewhere in here, because if I start north and I go east, I would have reached an angle of 90 degrees. However, they want 70 degrees. So if you know that knowledge, then you would know that if this is north, right, this broken line is representing east, which is 90. That basically means that if I want 70, it is somewhere between the north and the east. It is called a sketch because when you have done this in C.X.C, none of the examiners are going to actually take your paper and measure to see if it is 70. However, they can visually look at it and know if it is representing a 70-degree angle, because they are basically just looking to see if it is coming between the north and the east. So when north is 0, east is 90, you want the angle 70. So therefore, it's going to be something like this. So it doesn't matter where exactly it is. Once it basically looks closest to the 90 enough, and they say the bearing of P from O, so that is where P is. Please always make sure that you put the angle. So let's go again. Starting point is O. Draw your north line. I know that 70 is going to be somewhere between north and east, which is 90. So you just draw a line somewhere there. It doesn't have to be perfect. You don't have to measure anything. You just need it to look like it is somewhere right there. Let me fix that up. And then what do you always do now? You always have to put the bearing, which is the angle there. And how do we know our bearing? Start at the north, go in a clockwise direction. And they are going to be looking to see all of these things here. So you don't have to have this broken line part. No, you're not looking for that part, right? But if you know that you're going to forget, once you have a bearing question, then you can draw your little thing right here and in the middle or so, like somewhere at the top right there, to help you when you're doing your question. But try your best to remember this, right? Try your best to remember the angles associated with your cardinal points. So the bearing of P from O is 70 degrees. O is the starting point. Draw your north line. 70 is somewhere right there. So you draw your line. That's where P is. And then you represent the angle using north clockwise. Right. Good night to everyone in YouTube. I see you, Mr. Costa, Miss Talia, Miss Gabrielle, Miss Teresa, Mr. Levy, Miss Alicia, and everyone else. Good night. All right, I hope you guys are understanding what we're doing so far. Let's move on to another question once you guys have finished drawing that sketch. So can I move on now? If there's anyone who's still writing anything down, please say so. But I'm going to move on now. All right, let's look at the next one. All right, let's try this one again. And it's all about our principles in mathematics, right? What some persons do not know is that the questions are going to change, but the principle always remains the same. That is something that my father taught me when I was like 5 or something like that, right? Because usually when I was, I think I was like 8, I was like sitting in his C.X.C classes from that age. And sometimes I used to wonder how the questions got so difficult, because I would usually be able to get some of those into simple ones. But he told me one day that I should just always remember that the questions are always going to change, but the principle never changes. So this question is different from the one before, but the principle is still the same. So let's go. The bearing of M from H is 115 degrees. What is the first thing that we are supposed to figure out? We need to figure out what is the
starting point.
What is the starting point? Well done. And when I ask the questions, the persons in YouTube, you can answer in chat before I give the answer to see if you are correct. So the first thing is starting point. That is correct. Can someone tell me though, what is the starting point?
H.
H. And as you can see, different question, different letter, but the principle remains the same. And that is perfectly fine, perfectly correct. So the starting point is H. So here is my H. After you have written your starting point, what do you do next? Anybody remembers? What do you always do next? What do I now need to draw? Draw my, what type of line?
The line that points north.
The line that is going north, so it's called the north line. And Miss Pengili, I see you with the correct answer as well, Miss Gabriel. So well done, people. H is the starting point, yes. The next thing we do is to draw our north line. There is my north. And then now, look at your cardinal points. So 0, 90, 180, 220, 360. Can somebody tell me 115 is supposed to come between which two? Let's go again. 0, 90, 180, 270, 360. Which two? North, south, east, west. Which are those two?
90.
Sorry, could you repeat that? South, east.
South,
or do you mean south and east?
South and east.
All right, south and east. So perfectly fine. Don't worry, perfectly fine. I understand what you're trying to say. And that is perfectly correct. So 115 is supposed to come between south and east. That means that when you are drawing your line, if this is where east is and this is where south is, your line has to be somewhere down. Again, they are not going to measure the line to see if it is really 115. All they are going to look for is if it is coming between east and south. And once you look at the line, it is obvious for you to know. That's the reason why you always draw the north line. So once you draw the north line as your reference line, once you look at it, you can know if it is between that and that or that and that. So our ending point is M. Put your M right there. And now always make sure you put the angle. If you put this alone, you are incorrect. Yes, I see you. I see you, Nathaniel. I see you. All right. So as I was saying, always make sure that you put the angle. How do we put in our angle now? Start at the north line. And what direction am I supposed to go in again? What direction? Because we always have to remember this. That's C word.
Clockwise.
All right, clockwise. And then you put the angle right there. All right, we have done 2 so far. The next one I'm gonna let you guys try. Try it a little bit first. And then I'll see if you're correct. You can see if you're correct as well. And for the next one, if there's anyone who wants to annotate on the screen and write and draw their sketch, you can do that. Right? We can give you that that permission to be able to annotate on the screen. Let's move on now. All right, here we go. Try this one. And remember, questions change, but principles never change. So draw your sketch. The bearing of L from P is 243 degrees. And remember, there are a few things that they always check for. They have to see the starting point, they have to see the ending point, they have to see the north line, and they have to see the angle. All right. So use your cardinal points to figure out which two the angle is supposed to lie between, and then use that to help you to draw your line. I'll give you a minute to do that. And then if there's anyone who wants to attempt it, you can go ahead. right, is there anyone who wants to try this now? I'm not sure if you know how to annotate on the screen, but let's do this one here now. So the bearing of L from K is 243 degrees. So from K, we know that K is our starting point. Make sure you have your north line. And then now, when I use my cardinal points, north, east, south, west, can someone tell me which two is it supposed to come between? Which two will it come between? North, south, east, or west? Which two is it going to come between?
South and west, sir.
South and west, all right, perfect. If it's
Okay.
coming between south and west, that means it's going to be somewhere here because this is south, this is west. So once your line looks anything like that, that should be correct. So that's your point. This is where L is. If that is all you have, you're going to be incorrect though. Make sure that you put in your angle. How do we do it? Start with your north line clockwise. That means my angle is on the outside here, 243 degrees. Yes, I see those people in the Google chat getting those answers correct. Well done. Let's move on again. Again, try this one once more. Questions change, principles never change. All right, let's try this one now. So the bearing of V from T is 340 degrees. So I wonder what you guys use for your starting point. All right, this is what I'm going to use for my starting point. Is this correct? So if I got this question and you were marking this question and you saw me use that for my starting point, would that be correct? Would you mark that correct?
No, sir.
All right, so that's not correct. And as I said, the principle never changes. So T is your starting point. It says the bearing of V from T is 340 degrees. So using your cardinal points, you should have figured out that it's between west and north. And I see Miss Powell telling me that it is between west and north. Well done, Miss Powell. All right, and so it's going to be somewhere right here because this is our north line. This would be our west line. And then now draw your angle. Starting from the north line, go in a clockwise direction, 340 degrees. So if you have that, Well done. And this is one of the main reasons why a lot of persons cannot do a bearing question. They do not understand the underlying principle. So once you get a full understanding of this underlying principle, then you should be able to overcome a major problem that a lot of persons have, which is getting that sketch correct. All right, let's move on ahead again. All right, this one is slightly different, but let's see if anyone will be able to get this one. It says P is 20 kilometers due east from P. So the question is slightly different, but again, the principle remains the same. Can you figure this one out? I wonder what the angle would be, because this question doesn't give us an angle, and we always need an angle. So I wonder what the angle would be. Can anybody figure out what the angle is? Okay, let me draw my sketch now and let's see if anybody would have had it correct. So it says P is 20 kilometers due east from T. So again, even though this question might be slightly different, the principles remain the same. So let us apply the same principles. It says from T, that means T is my starting point. Draw your north line. And it says that P is 20 kilometers due east. If we use our cardinal points, then we should know that east is that direction right there. So this is where my P is going to be, due east from T. They say 20 kilometers due east, so you would have to put the 20 kilometers. And if we use our cardinal points, we should remember that east is 90 degrees. So if you're able to get that, well done. If not, then you should see what you did incorrect. So the T is still the starting point, but because it says due east, then you have to make sure that P is directly east of T. And how do we do that? By making sure that our angle is 90 degrees. Next question. The last one, and then we move on to some harder examples. K is 54 meters due south from A. So K is 54 meters south from A. Based on what you saw me do for the previous one, let's see if you can get this one correct. All right, hold on. I just saw a question from Mr. Levy. Just saw a question from Mr. Levy, and it is based on this right here. So let me draw back the diagram quickly. All right. The question that he's asking is that he wants to know if we do not have to write 090. All right, which is obviously representing our 90 degrees. Remember that this is a 90-degree angle, right? So even though when you're doing bearings, you have to represent it using 3 digits. The fact that this diagram, this set diagram itself represents a 90-degree angle. If you use this, you are not going to be marked incorrect. Right? So if you use this, you're not going to be marked incorrect, and I hope that answers your question right here. Let's go back there now. So K is 54 meters due south from A. I see Miss Powell telling me that it's 180 degrees. Okay, let's check and see if that's correct. So K is 54 meters due south from A. From A, that means A is our starting point. Always have your north line. Due south, this is north, this is east, that is south. So it's going to be straight down there. And the angle is going to be 180 degrees because south is 180 degrees. Perfectly correct, Miss Powell. And that will cover those simple ones there. All right, let's look at some harder examples now. If the bearing of A from B is 65 degrees, determine the bearing of B from A. So this is basically a two-part question. The questions that we were doing before were saying something like the bearing of A from B is 65 degrees, and then that's it. However, this question now wants us to try to determine the bearing of B from A. And if we remembered what I said earlier, whenever we are being asked to find a bearing, what that means is that they are actually asking us to find an angle, because a bearing is an angle. So again, you always require a sketch, and the question might have changed, but the underlying principles that we just looked at remains exactly the same. And that's what we're going to use to help us now to answer this question. So if the bearing of A from B is 65 degrees, determine the bearing of B from A. Start by drawing a sketch for the first part of the question, which says if the bearing of A from B is 65 degrees. Can someone tell me, either in our chat here or in the live session, what is supposed to be the starting point for that part of the question? If the bearing of A from B is 65 degrees. Is the starting point A, or is the starting point B? And is the angle, and what two cardinal points is the angle supposed to go between?
B, north and east.
North and east, perfectly correct. And whenever you get a question, that has to be the way how you break it down, by using your little tips, the things that you look out for. All right. So the starting point is B. And we do what we always do. Once we know what our starting point is, draw the north line. There is our north line. Figure out what two cardinal points it's supposed to come between. It's supposed to come between north and east. Use that to help us to figure out where our line is supposed to be. There is our A. And remember, always put your angle north clockwise. That is my 65 degrees. Once you have drawn the sketch for the first part of the question, let's now go to the second part of the question. It now says, determine the bearing of B from A. So what's the difference here? What's the difference between the bearing of A from B and the bearing of B from A? What's the difference?
Um, 99, 65.
So did I hear you say that for one of them, the starting point is B, and for the other, the starting point is A? And that's perfectly correct. For the first one here, if the bearing of A from B is 65 degrees, for that one, the starting point is B. But here now where it says determine the bearing of B from A, the starting point is going to be A. Let me draw it a little bit down here. Give myself some more space. That's my north. That's my A. That's my 65. Let's now do the second part of the question. If my starting point is A, then we do what we always do. Start by drawing the north line. However, what they want us to find is that they want us to find the bearing or the angle. How do we get the angle? Start at the north line again. And what direction do we go? We always go in the that special C word.
Clockwise.
Always go in the clockwise direction. So what that means, let me take the A out of it. What that means is that they want us to find the angle on the inside right here. And I'm going to use X to represent it. All right. So if the bearing of A from B is 65 degrees, determine the bearing of B from A. So when we sketch our diagram, this is what we're left with, but this is the angle that they want us to find, the angle X right here. Is there anybody who sees a way how we can work this answer out? Can anybody tell me what type of lines, are these two lines? It starts with a P. What type of lines are these two lines?
Parallel.
Parallel line. All right. And if you remember, I started class by going through some principles related to when we have two parallel lines that are joined by a line that we call a transversal. There are some special type of angles that are formed. Does anybody remember the type of angles that are on the inside? What are the ones on the inside called again? When you decorate it's close to when you decorate the inside of your house. What are they called again? And they start with a C. Oh, Mr. Clark, what we're doing bearings. Good night to you, Mr. Clark. We're doing bearings. I see Miss Powell telling me that she thinks the answer is 25 degrees. Okay. All right. If you don't remember that these two angles on the inside, whenever you're doing a question where you're given parallel lines and we're talking about two angles on the inside, those two angles on the inside are called co-interior angles. Oh, sorry, wrong one. All right, so they want us to find this angle X right here. But the only thing I was given is the angle right here, 65. And I can't just use this angle to find that one. However, if we realize we have two north lines which are parallel, so we have two angles on the inside of those parallel lines. Those two angles are called co-interior angles, and we can now use the principle of co-interior angles to find this one. It is not, all right? If you remember the principle that I told you earlier, co-interior angles are supplementary. This is a word that everybody please make sure that you know this word, supplementary. It is a very important word in mathematics. All right. Co-interior angles are supplementary. What does supplementary mean? It means adds up to 180 degrees. So please jot that down somewhere. This is very important information. Jot it down in your book, circle it, highlight it. Very important information. So I said that supplementary and I said that co-interior angles, sorry, are supplementary. So what that then therefore means is that what am I supposed to take the 65 from? So if these two angles are supplementary, what am I supposed to take the 65 from?
180.
180. And when I do that, what do I get for the answer?
115.
115. Perfect. And I see Mr. Levy and Miss Gabriel telling me my co-interior angles. Perfectly correct to those two as well for figuring out that they were co-interior angles. And perfectly correct to you guys for figuring out that this angle is supposed to be 115. How did we get that answer again? These are two parallel lines. We have two angles on the inside. Those angles are called co-interior, and we say that co-interior angles are supplementary. What does that word mean? It means that they add up to 180 degrees. So when we take that 65 from 180, we get 115. However, is this the angle that they want me to find, or is the one on the outside the one that they want me to find? Because when you're doing a question, you always have to make sure that you answer what you are asked. You can spend 10 minutes working out a question and everything that you did is correct and still get 0 because you did not answer what the question asked. And that's a mistake that a lot of students make, right? They just start working out a question, do not ensure that they actually answer what the question is asking them to answer. The question here is asking me to determine the bearing B from A. When I started at my north line and went in a clockwise direction, the angle that I got was the angle right here marked in X with blue on the outside, which means that I still have not gotten my answer as yet. I am now going to draw on another principle in mathematics, and it is this one. So let me write it on the screen quickly for you to write it down. Angles at a point add up to 360 degrees. And based on that principle, can someone think they can figure out the answer now? Right? So if we're going to use the principle of angles at a point, and as you can see right here, this is our point. We have one angle here, another angle here. Can someone work this out quickly and tell me what is my answer now? What is the actual answer equal to? I see someone say 245 degrees. Do you guys, are you guys watching on YouTube? Do you guys agree with her? So I see let's see who wrote it. Miss Tangini said 245 degrees. How about you guys on YouTube? Are you agreeing with her? Let's see if anyone agrees with her. Or do we think it's something different? All right, well, let's work it out though. If these are angles at a point and they add up to 360 degrees, when I take my 115 from the 360, my answer is indeed 245 degrees. And I see that Mr. Levy had agreed with her, and Miss Gabriel as well got the same answer. Well done. Let's do another example quickly, then I'll give you a few to try. For you guys to test what we have done so far to see how much you would have understood. The bearing of P from Q is 170 degrees. Determine the bearing of Q from P. So let's do this quickly. Again, questions change, principles remain the same. So the bearing of P from Q is 170. From Q, that means Q is our starting point. So my Q, north line, 170, that's going to be between east and south. There is my P. Always put your angle north clockwise, 170 degrees. It now says determine the bearing of Q from P. So Q from P, that means this time P is my starting point. So that is where I put my north line. They want us to find the angle. How do we represent the angle? Start at the north line, go in a clockwise direction. So that means the angle that they want us to find is this one right here on the outside. So I hope you guys are realizing that this one, the question is different, but the principle is the same. It looks kind of like the one that we did before. Let me give you a minute to see if there's anyone either in the YouTube chat or in live who can give me the answer for this one. All right, so let's go here now. So again, questions change, principles remain the same. Based on the principle that we learned before, we learned that when we have our parallel lines here, angles between them, the angles in the middle, these, I mean, not in the middle, the angles on the inside, these angles are known as co-interior angles. We said before that co-interior angles are supplementary, and the word supplementary means that they add up to 180. So to find this angle there, I have to take the 170 from 180, and that's going to give me 10 degrees. Remember, you're doing bearings, so make sure that you're using your 3 digits. Right, so make sure that you're using your 3 digits. If we stop right there, we're going to be incorrect because the angle right here marked X, that's the one that they want us to find. The angle marked X, that's the one that they want us to find. How are we going to find that now? Utilizing our next principle called angles at a point. And we said that angles at a point add up to 360 degrees. So we're going to have to take the 10 degrees from 360. And when we do that, we end up with our answer, which is 350 degrees. Okay, let's give you guys something to try on your own now. Remember, questions change, principles don't change. There are 5 questions here now to challenge you to see how much you would have understood all that we have done so far. So let me give you about 10 minutes or so to work this out. And then let's check your So about 5 more minutes. All right. Let's sort these out. And then afterwards, I have a few mixed questions to give you guys to try. All right, so question one. Given the bearing of M from O is 114, determine the bearing of O from M. So let's go through these quickly. M from O, that's my north, 114. and they now want the bearing of O from M. When I take this from 180, I get this angle, which is 66 degrees. And then to find the answer that they want us to find, I now take this angle from 360, the answer for the first one, 294 degrees. Remember, you have to use your 3 digits. So the answer for question 1, 294 degrees. If you got that right, give yourself a tick. If not, make your corrections quickly. Question 2. The bearing of L from V is 100 degrees. Determine the bearing of V from L. So the bearing of L from V is 100 degrees. Sorry, L from V. North line, 100 is something like that. L is right here. They now want us to find the bearing of V from L. So north line, put your 100 right here. This is what they want us to find. If this is 100, co-interior angles are supplementary. 100 from 180 gives me 80. If this is 80, angles at a point add up to give me 360 degrees. So when I take the 80 from the 360, my answer is 280 degrees. Again, if you got that one correct, give yourself a little tick. If not, make your correction. Question 3, the bearing of A from B is 60. So from B, 60, something like that. That's my A. Ensure that you have your angle. Determine the bearing of B from A. North line right here. Start at the north line. Go in a clockwise direction. This is the angle that they want us to find. If this is 60, and these are co-interior, then this angle is 120 degrees. If this is 120 degrees, and these angles are angles to point, and we see that angles to point add up to 360, then X is equal to 360 minus 120. X is equal to 240 degrees. All right, question 4 and question 5. If you got question 3 correct, give yourself a little tick. If not, make your corrections quickly. Questions 4 and 5. If the bearing of I from K is 216, determine the bearing of K from I. So I from K is right here. North line. I is going to be, 216 is between south and west. So it's somewhere down there. So this is my I. Put in your angle. That is my 216. They now say determine the bearing of K from I. So north line at I. And then what is the angle that they want? Start at the north line, go in a clockwise direction. This angle right here is the angle that they want us to find. So this is a perfect example of question being different, but principle being the same. So this is slightly different because usually all the ones that we did before, they wanted us to find the angle right here. This time we have the angle right here and they want us to find this right here. However, we still use the same principles. These angles are angles at a point. So if I take this 216 from 360, I end up with the angle right there, which is 144 degrees. So this is 144 degrees. So that principle remains exactly the same. And then if I want to find x right here, I still see two parallel lines, angles on the inside, co-interior. So that principle remains the same. Co-interior angles are supplementary. So x is equal to 180 minus that 144. X is 36 degrees. If you got that one correct, give yourself a little tick. If not, make your corrections. Let's now look at the final one. The bearing of T from H is 300. Determine the bearing of H from T. So T from H is 300 from H. So H, north line, 300. Hold on, let me draw it down here. 300 is going to be between west and north. So it's something like that. Put my T. My angle, north line, clockwise. That is my 300 degrees. They now want us to find the bearing of H from T. T is now the starting point. North line. Start at the north line, go in a clockwise direction. This is the angle that they want us to find. Utilizing the principles that we have been using, 300, and the angle that I'm going to mark in blue. Oh, whoa. So 300 and the angle that I'm going to mark in blue. These angles are called angles at a point. They add up to 360 degrees. So when I take the 300 from the 360, that's how I'm going to end up with 60 degrees. And so this angle is 60 degrees. I want to find x. X and 60 degrees, these two angles are called co-interior. Co-interior angles are supplementary. Supplementary means that when I add them together, they add up to 180. So to find x, I take the 60 from 180. My answer is 120 degrees. Okay. All right, so if you got those correct, give yourself a tick. If not, make sure that you make your corrections. All right, and the persons in the Google chat, you can let us know how many of those questions you got correct. All right, we still have a few minutes left. So I'm going to take this time now to do a little mixed questions, a few little mixed questions. Because this ends the first part of bearings, which is just the introduction. So next week when we have our next live session, I am going to go into the C.X.C style examples and show you how we use these same basic principles here to answer those type of questions. All right, let me get my whiteboard up. All right, let's look at this question now. If f of x equals 2x plus 1 g of x equals 3x minus 2. Evaluate. Question 1, f of 3 Question 2, g of negative 5. Question 3, g f of 3. Question 4, f inverse 1. Right, so these are some questions based on the topic called functions and relations. These are questions that are very common on the exam paper. If you do not see one of these type of questions on paper 2, you are definitely going to get a couple questions based on these principles on the multiple choice paper. So this is something that we have to make sure that we know how to do. So I'll give you a minute to start working out a few of them, and then I'll discuss the answers. Okay, let's go. What is the principle that we use to answer these questions? The main thing that you need to know is that you are going to replace x with whatever you see inside your brackets. So for question 1, I have f of 3. So the principle says replace x with anything that I have inside the bracket. It says if f of x is equal to 2x plus 1 and g of x is equal to 3x minus 2. So what you have to do is to make sure that you choose the correct function. If you use this one, you're going to be incorrect because the name of the function is the f function, so we have to use f of x. F of x is 2x plus 1. Remember that we are supposed to replace the x with the number in the bracket, which is 3. Please do not make this mistake. What a lot of persons do is that because they here replace the variable x with the number in the bracket, which is 3, they just replace the x with 3, but they forget this principle. Does anybody know what 2x actually means? Right, in mathematics, when you see a coefficient and a variable, what is the coefficient doing to the variable? And the coefficient is basically whatever is basically beside the variable. What we say is basically anything that we're multiplying our variable by. So our variable is x, 2x actually means 2 multiplied by x. So to show this multiplication operation, we are going to utilize parentheses or brackets. Again, in mathematics, brackets can be used to represent multiplication. And so what is our actual answer now? 2 times 3, because remember, you multiply before you add. 2 times 3 is 6, plus 1, my answer is 7. As I said, a very important topic that you have to know. If it doesn't come on paper 2, and usually you will get like even 1 question or so, but on the paper one, on the multiple choice, you always get these principles, and especially this one. This is a simple one here where you simply find the image of the function. All right, next. We now have g of -5. We're now using the g function, but the principle still remains the same. Replace x with whatever you see inside your bracket. However, this question, we need to start by using the correct function, which is the g, and that one is 3x minus 2. In our bracket, we have -5. So replace the x with -5 minus 2. Remember, positive times negative always gives you a negative. So my answer has to be -3 times 5, 15 minus 2. What's the answer for this? A lot of persons write back the minus sign, then they say 15 minus 2, 13. So -13, that's not correct. That's not how we work out this. All right. So minus 15, you owe 15, minus 2, you owe 2. If I owe someone 15 and then I owe them 2 more, how much do I actually owe them? Can someone tell me that? So if I owe you 15 pence, and then let's say I borrowed 2 more pence from you, how many pence do I actually owe you?
17.
17. And because when we're working it out this way, we use O to basically, O, the word O, it's representing a negative. So if I owe you 17, my answer is -17. Next question, question 3. This one, G, F of 3. GF of 3. So this one is slightly different from the ones that we have done so far. This one has a combination of both of the functions. This function is called a complex function or a compound function. Some people call it a compound function. Some people call it a composite function. Some people call it a complex function. All right. But in most books, you'll see composite function though. But all it is just a combination of 2 or more functions. However, the principle is going to remain the same. Remember that when you're answering a function question, you always replace x with whatever you have inside the bracket. For question 1, I had 3 in the bracket. For question 2, I had -5 in the bracket. Here for question 3, you're going to realize that you have 3 in the bracket. But this is what I'm going to do when I'm working out a question like this. I separate the 2 functions by adding a bracket right here. So what that actually means is that inside the brackets, I actually have f of 3. And remember what the principle says. It says that I replace x with anything at all that I have inside the bracket. All right. So inside my bracket, I have f of 3. Let us start by writing our g. What is my g? 3x minus 2. That's now equal to, replace the x with whatever is in the brackets. But if we remember, f of 3 is the exact same thing that they asked us to find for question number 1. So we're going to use the same answer. F of 3, when I work it out, I got 7. So what that means is that I'm supposed to replace my x right here with 7. I now have minus 2. 3 times 7, 21. Minus 2, 21 minus 2. My answer is 19. And I see those people in the YouTube chat giving us their answers. I see that most persons have correct answers. Well done to everyone. Then the final question for this one, question 4. F inverse 1. F inverse 1. In order for me to work out F inverse 1, I first need to figure out what F inverse X is. And then when I figure that out, I replace the X in this one with the 1. So how am I going to get F inverse X? Start by writing the original function. F of X is equal to 2X plus 1. Replace the function with the letter Y, with the variable Y. So Y is equal to 2X plus 1. You now interchange your variables. So wherever Y is, I put X. So X is now here, is equal to wherever X is, I put Y. 2Y plus 1. And then I now solve my equation for Y. Whenever you're solving an equation, you're trying to get the variable that you want to find on a side by itself. So we work this out by using a process that we call transposition, which is where we move things from one side of the equal sign to the other. So we want to get Y by itself. We're going to start by transposing the 1. I'm going to get X. When you transpose, you do the opposite. The opposite of plus 1 is minus 1, is equal to 2Y. I still have not gotten Y by itself. So I'm now going to divide both sides by 2, because remember 2Y means 2 multiplied by Y. So to get rid of the 2, I'm now going to divide. When I divide, those 2's are going to simplify. Y is equal to X minus 1 over 2. If you leave your answer there, that's not correct. They want us to find F inverse 1. What we have just done is to figure out what F inverse X is. So now to get F inverse 1, we use the same principle that we have been using from before. Anything that I have inside my bracket, I replace the X with that. So X, I'm going to replace that with 1. 1 minus 1 over 2. What is 1 minus 1? 0 over 2. And what is 0 divided by 2? My answer is 0. Okay. Before I close my session off, let me give you another question here. Question number 1 on every C.X.C paper always contains fractions and decimals. Let's see how many persons can get this correct. This is an actual C.X.C question, and it was valued 3 marks. Let's see if there's anyone who would be able to get all 3 of those marks.
All right, cool.
Okay, let's start discussing this. This type of fraction is called a complex fraction. Right, this type of fraction is called a complex fraction. And the main thing for you to know is that the line that separates the numerator from the denominator, this line right here represents a division operation. So what that means is that I'm actually dividing whatever I have in the numerator by what I have in the denominator. So to work out a question like this, the first thing you do is to work them out separately, then you divide your answers. So let's start with the 1.5 minus 2/5. Minus 2/5. Let's start by converting this to an improper fraction. 2 times 1, 2 plus 1, 3 over 2 minus 2 over 5. What's the principle here? When you add or subtract fractions with different denominators, you find the LCM. The LCM means what's the smallest number that the denominators can go into. The smallest number that 2 and 5 can go into is 10. 2 into 10 is 5. 5 times 3, 15. Minus 5 into 10, that's 2. 2 times 2, 4. 15 minus 4, I get 11 over 10. Divided by, let's now work out the denominator. 4 2/5 times 3/4. 5 4 is 20 plus 2. 22 over 5 times 3 over 4. Let's simplify. 2 into 4 is 2. 2 into 22 is 11. I get 33 over 10. So 11 over 10, I need to divide this by 33 over 10. How do you work this out now? The next thing that you now need to remember. So as you can see, for this one question, they're testing if you know how to subtract fractions, multiply fractions, and divide fractions. That's why you're given 3 marks. When you divide fractions, you multiply and reciprocate. Reciprocate means that whatever the denominator is, that it now becomes the numerator, and the numerator becomes the denominator. We now simplify. 10 into 10, 1. 10 into 10, 1. 11 into 11, 1. 11 into 33, 3. My answer is 1/3. If you got 1/3, then you would have gotten all 3 of those marks. All right, everyone. This is where I'm going to close off my session. It was my pleasure being here, and I'm going to be here next week, Monday, for part 2, where we go through C.X.C style questions based on bearings. I hope everyone learned a lot. All right. You can write in chat if you're interested in joining the CDP Labs program, you can write that in chat and the moderator will get through to you. As well, if you would like, you can as well join us here next week, Monday, same time from 8 to 10. Please try to be early. Please try to make sure you come with the knowledge that you learned today, because we're now going to be using it to answer some, I'm not going to say difficult, but some nice C.X.C style questions. All right, so I'm now going to hand over back to Mr. Bernard. Good night, everyone.
All right. Tangini, are you there?
Yes, sir. So good night again, everyone. On behalf of the CDP Max Lab students, I would like to extend my gratitude to Mr. Foster for coming to extend his knowledge on bearings and also mixed questions.
All right. Thank you. It was my pleasure. And once I'm available, I'm always here to help.
I am sure that this will be of great help to us, and I hope we'll use it in the future. Thank you.
Thanks once more. Thanks once more.
Okay. Thank you very much, Tangini. And we look at the clock, it's 10:08. But before we go to that, I also want to say thank you to Mr. Foster. You have done a wonderful job. I mean, of course, I don't know if you had streamed before, but of course, you actually interacted with everybody, both on Zoom, on YouTube, and that was wonderful, right? When we come to the end of the class, we usually ask the students to give their what you call it now, their feedback of the class. And of course, you have heard Tangini given on behalf of the class. All right. I also want to say a special thanks to all the persons who have always been supporting CDP Labs and their services. I want to say thanks for you as well. I see the Alicia, the Teresa, the Gabriel, and I also want to continue to extend a special welcome and thanks to students such as Jaron Harrison, Noah Levy, also that's Perry, Tahelia Perry, Delicia Atti, Angel Da Costa, and Donna, and all of you who have participated, Raheem Clark as well. I want to say a special thanks to you all for participating. And as you have heard, Mr. Foster says next week, Monday he'll be here to deliver part 2. Now, we normally have a game competition. Don't know if you guys want to do the game. We have two students still remaining with us. The others who have lost them because of internet connectivity issues, they are also in the chat. But before we go any further, though, we want to ask the persons in the YouTube chat to give us your feedback for today's class as well. And Nikosha, are you there? Sister Nikosha, are you there? Miss Gooden? Miss Gooden, probably not hearing me. All right. All right. So while Teresa says the class was very entertaining. This is the Foster. Should I tell him about that entertaining word too? Is there Foster? Rashid, are you there? Foster, are you there?
Yes, man. I'm here.
Well, Mr. Foster is indeed an entertainer as well. / entertainer. He is an entertainer as well. All right. So okay, I guess one of these days he might just give us a piece of the music. Right? So thank you, Teresa,
Yes,
for
I
that.
might invite you.
Hey, what's the faster? Is it?
I might one of these days. I might.
Yes, man. Of course. All right. So we got Teresa saying very entertaining. Very good. I'd like to hear from the others. We got Teresa. What about the others of you? Gabriel, if you're there, and so forth. Okay, Gabriel says, Sir, class was very informative and exemplary. I learned a lot. So, Mr. Foster, excellent job. All right. All right. So as we wait for the other things to come in, we're gonna close the curtain down now. Next week we'll arrange to let you do the quiz. Do you want to do the quiz first, or you want to just close? What do you think?
Come on, let it stay till next week.
Next week, where?
Because next week now we'll have more time to do the quiz and more, because all we're focusing on next week is just a C.X.C style question.
All right, no problem.
Everybody, make sure that you walk with that bundle of knowledge next week.
All right, exactly. All right, so next week we will return with our quiz, our weekly quiz, and of course, Mr. Foster will return to us. And on behalf of the CDP Labs family, the management of CDP Labs, I also want to say thanks to you, Mr. Foster. And of course, we're going a long way, and this is the beginning of something great to come. So let us give God thanks for that. And thank you very much to Tangini for giving us a vote of thanks. And of course, thanks, Nikosha has been participating. And for those students who was in Zoom, thanks to Tarsha, thanks to Lexi, thanks to Ashe for also being a part of the class. I pray that when next week comes, I told you guys, I told them from last week that they cannot miss this. And of course, persons in fact turned out. Other students are a part of it, but I'm not sure that SBAs have them a week. So I hope their SBAs are through now, that they'll be able to participate next week. All right, so that's it. Mr. Foster, just wait till everybody gone, okay? Don't move. All right, good night, folks. We'll be ending our stream at this point. So take care, keep healthy, and have a good night. Tomorrow night, we'll be streaming English language live, same time, same place at 8 o'clock. And of course, we will be streaming live on Wednesday again, our human and social biology class on same place, same time at 8 o'clock. So tomorrow night, we'll have our English language night with Mrs. Riley, as you know. And then on Wednesday night, yours truly will be back for human and social biology. So please do have yourselves a wonderful night and take care until next week. One second. Let me screen share something.
They said you wouldn't make it so far.
Are you interested in finding a school to enhance your education? Not sure where to start? Well, today your search is over. CDP Maths Lab eSchool offers classes for C.S.E.C, CAPE, and GSET subjects, along with training in early childhood education and data operation. Listen to what CDP Maths Lab students have to say about their most fulfilling experience.
While I was attending, it was almost the best experience I ever had. Like I was in class, but I wasn't. I would give the school the full 10 out of 10 because the teachers take the opportunity to help the ones that really needed it. To the upcoming students, this is the best decision you have made, and it will benefit you in the near future.
CDP Maths Lab E-School was founded by Ronique Bernard in August 2009 with a vision to see our students receive a solid education with an emphasis on developing their cognitive skills. The school is committed to developing individuals who will have a positive impact on the society.